There you go, Sam. All right, here we go. So factoring and solving quadratics, today is the second lesson of that. One of the things that you may pick up on is there's a couple of shortcuts that you might be able to figure out. But here's what I know. Even though the diamond problem and then the area model are kind of putsy and a little time consuming, they really do help keep everything organized. You're welcome. They really do help keep everything organized and in a place methodically, so that it kind of really is a fail safe, right? Which means, like, if you follow all the steps that we've done, you shouldn't get the problems wrong. Jesus, can you close that for a few minutes, please? Jesus, can you please close your Chromebook? No, not yet. No. All right, here we go. So again, on your paper, lesson 2, today's date is 5/7. And let's just get right into our first example. So it's a great continuation of what we talked about on Tuesday. So again, we're going to write this expression in factored form. We're going to use the diamond problem. We're going to use the area model. And remember, when we talk about factored form, everybody, we're looking for what's going to go inside those parentheses. And the stuff that appears on the outside, the top of the rectangle and the side of the rectangle, remember that's what goes inside the parentheses for that factored form. Jesus, you need any paper, buddy? Okay, can you put your phone away also, please? Thank you. All right, so I believe we talked on Tuesday when we were in class. Notice in this first algebraic expression, the regular x term is missing. And I think we talked about it towards the end of the hour that if we don't see an x term in the middle, you can treat it as if there is a 0. And then we've got this minus 49. And then again, the reason why we want to make sure that we keep that in mind is that when we figure out the diamond problem, remember, whatever the x term is, that's the number that goes in that space. So we know that we need a 0 in there. We need 2 numbers. What number is going to go up here in the top of the diamond problem? Yep. Someone here in the classroom said this one needs to be negative 49. So we know that the number on the left and the number on the right need to multiply to make negative 49, but we know that they also need to add up to 0. One moment. Hello, sir. Sure. Yeah, yep. Mm-hmm. 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 Okay. Oh, okay. Yeah, no, that's great. I think that's perfect. And like I said, it was a surprise and we didn't necessarily think there was anger in it. But you know how what happens, like that whole, a little bit leads to a lot. All right. Thank you, sir. Happy Friday to you. Thank you. Bye-bye. All right. Go ahead, Kenzie.
For the top triangle of the diamond, it's always A or C, correct? But for x squared, what if there's something in front of the x squared? Because that is in front of the x, right?
Good question. So you always, if there's a number, a coefficient right here in front of the x squared is what you're asking, right? So the question is, how do we know for sure what goes here? And you always do A times whatever C is to get what's inside the top of the diamond. And because there's no number next to this x squared, remember it's an imaginary 1. So 1 times negative 49 is what gives us this 49, right? So if it was like 3, you would do 3 times negative 149. Yeah? Yep, you're welcome. All right, who's got the answer to what should go on the left and the right here? What 2 numbers are we going to put in there? Ashley? Yeah, does it matter which one gets 7 and which one gets -7? No, it doesn't. There you go. Some of you might have already filled that in already. Okay, and then once we know these two numbers here in the left and the right, we know that we're going to use those to fill in our spaces here. One of them is going to get 7n, and one of them is going to get -7n. Oh, whoops, I should use an X. Yep, where's my eraser? Whoops, it erased it all. I don't know how to just delete those ones that I did. Yeah, I'm sorry, it should be X's. Do you guys need me to put that writing back up there, or are we okay? The A times C. Some of you don't even know what I had up there, do you? That's fine. So it was like this, x squared plus 0x minus 49. I think I got it all. All right, and so once we know those two terms, the left and the right, then we fill in the square. And then we know here we're going to put x squared. And in the lower right, we're going to put -49. And so then we take a look at those terms. We typically start in the upper left-hand corner and we look for that greatest common factor. So what's the greatest common factor between x squared and -7x? Correct. So I'm going to take an x out. And if I put an x here on the left, I know x times what gives me x squared? You got it. And if there's an x here on the left, thank you. I was going to go here to the top right. We know that one needs to be -7. What does it need to be? 7. Right? Because 7 times -7 does give us that -49. That should be 49, not -4g. Sorry about that. So once we have that information on the outside of that rectangle, that's what goes in the parentheses for the factored form. So we know then in factored form, this will be x plus 7 times the quantity of x minus 7. Yeah. Notice anything special about what's in the parentheses compared to the original problem? Go ahead, Sam. Yeah, in this case, it worked out that way. I put that back, you guys, because all my writing moved. I don't know what happened. So, yeah, and it happened typically in this case because with that x gone, what can you tell me about the number 49? Anybody? Remember it was, what is it, x plus 7 times the quantity of x minus 7? 49 is a perfect square, right, you guys? Yeah, x squared is a perfect square, right? Now, just so you know, this particular problem has a special name. It's called a difference of perfect squares. Difference meaning subtraction. X squared is a perfect square. 49 is a perfect square. So you can split them up. One gets plus, one gets minus. Okay, but you don't necessarily have to remember that, which is why I started today's lesson with the fact that we know this is a pretty fail-safe option if you follow the steps to fill in each of the spaces. Okay. All right. Does everybody have what you need on this slide? Does anybody need more time to get everything written down? How about my at-home friends? Anybody need more time? All right, let's go on to the next example. All right. Here's the next example, 25x squared minus 1. All right, based on what we've talked about, what am I going to put in this upper part of the triangle? It's not a triangle, diamond. Yep. And again, we did that because we know we have to do 25. Yes, very good, times -1. Repeating it for at-home friends, by the way. Jesus, you good, buddy? Okay. All right, folks, what's going to go in the bottom part of the diamond? Remember, the bottom part of the triangle is, or the diamond is whatever is next to the plane x term in that equation. And in this case, 25x squared minus 1 does not have an x squared, or I mean a square, oh my goodness, does not have an x term because it's missing. We have nothing, so we're going to put 0. Kenzie, go. No, it doesn't affect it. So if you want to, when you see problems like that and there's something missing, if you want to add in that term like that, just as a reminder, absolutely go ahead and do so. Yep. All right, what two numbers are going to go on the left and the right of our diamond? Anybody at home? Anybody? Bueller? Bueller? Hello, people at home, can you hear me? Thank you, Betsaida. Okay, and I know some of you said it here also. Why would you use -1? Because I thought you used. Okay, Emma G, good question. So the question here in the chat is, why did we use -25 right here? The question is, why did we use -25 and not -1? Sure, I'll have one. Oh, Matthew, I didn't see that. Yes, you can have one of the apples too. All right, Evan.
Well, when we -1 and 25 that's squared, so it's 5 times -1.
Yeah, I don't know. Can you guys hear him at home? I know it's kind of hard. If you didn't hear him, remember the rule is you have to figure out the top of the diamond, you have to, in your quadratic equation, do A times C. Remember, the A is the one that's with the squared term, B is with the x term, and then C is the number that's plain and all by itself. Yeah. So that's what Evan was saying. Thank you for letting me know. I didn't know if you guys could hear the kids here in person talking or not, but that's what he was saying, is you have to do the A times C to figure out the top of the diamond. All right, that being said, we're going to move our 5s over, and we've got an x in that equation, so I've got 5x, and I've got -5x. And in the upper left-hand corner, we've got 25x squared. And in the lower right-hand corner, we've got -1. Can we see the purple okay? Okay, I'll switch it. Okay, what I would like you to do is take a few moments, and I want you to finish the problem and get the stuff that appears up here at the top and here at the bottom. Well, that made it really clear. All right, so get the top part and get the bottom part so you can get it all factored. All right, anybody want to share what you got? I move the gray rectangle. Kenzie? So 5x plus 1, 5x minus 1? Okay. Right, so if we do that breakdown, the common denominator here, good gravy. Greatest common factor, this would be a 5x, and then this needs to be a negative 1, and that would be a positive 1. Nicely done. All right, so again, it's just building off of what we did previously. Again, this is another difference of perfect squares, but you're not going to be tested on whether you know that something is a difference of perfect squares, because again, I think this procedure with the diamond and the area model help you stay kind of in order and keep everything in check. Question?
It doesn't matter what order it's written. Like x squared will always be a, and then the bigger number will always be c, and x will always be b.
Correct. Yep. All right. So go ahead, and now we will switch to that assignment. Go ahead and open up Schoology. If you've been in Schoology already once today, Jesus, do you need to charge your other Chromebook? Because I've got chargers. Okay, so once you get organized, if you open up this gray and red cabinet here, the right door, pull it, it's kind of snug, so you got to give it a good pull. There's cords down there in the little blue and white. Yep. And there's an outlet behind by the calculators. All right, so again, you are going to go into Schoology, find that homework number 2, and then you can do your work on your notebook paper, take a picture, and post it on your DUR. Again, if you have not done that with the lesson 1 assignment yet, let's make sure that you do that as well. I will get grades updated over the weekend.